Alright, so I haven't messed with this board at all. I just found a random power supply I had laying around, and it didn't work. So basically, I'm gonna use this as a demo. I got a nicer iron, so this thing heats up really fast. Remember that with a lot of irons, even though they're cheaper, you can find replacement tips of different sizes for them. So I've got a drawer full for mine with multiple sizes. So mine is interchangeable. So there's that. There's another little guy that's just a little bit more angled. Then there's also this big ass shovel, and here's what I'm currently have on there, right? So remember that when you're running iron, even though it's cheaper, you may still have tip options, and if you can get a better tip for the job, it's going to save you a lot of pain in the ass. All right, so as you can see, these are all through-hole components. So this one right here is the one I'm going to go after. It's the 3-pin type of power regulator, MOSFET, multiple different things that type of component can do. This one I believe is a power or voltage regulator. So what I'm going to do is I am going to start, and I haven't touched this before, so these solder joints might be older, but one method I found that works quite well, especially when you're removing multiple pins and you don't want to trash PCBs or these traces, or rip them through or dig holes in the PCB, is to add enough solder that you actually bridge all of them. It seems kind of counterintuitive, like that doesn't make any sense, but we're going to try to, once I can balance it, this is a fun thing too, I'm going to try to add a bunch of heat to it. And I apologize, I'm kind of shaky right now because I'm actually working through the camera screen and there's a little delay there, so it's going to be a little bouncy. So basically, I'm holding the tip up against the pin, and I'm feeding more solder in. So I'm trying to add solder and get that one that's already there to flow, which you can see is kind of working now. So all your solder is going to have some sort of flux in it. They're called a flux core. This one I believe is a RMA style, which is going to leave some residue on there, but it's not necessarily bad for the board. Water soluble could be bad because if it stays on, it could start messing with traces and eroding stuff. Water or no clean flux is good. You don't have to clean it, but it's a huge pain to work with because it evaporates so quickly. So now if we look, that's that component that I just bridged all of those, right? So the point here is that I am bridging all of these so I can apply heat simultaneously to all 3 pins. So in theory, if I have heat on here long enough, it's going to flow through all of this. This whole joint is going to flow, which in turn will heat the ones underneath it, which are part of that component, or all tied in that component. So the trick is to apply pressure to this component as I'm heating it. So what I'm going to do is I've got my tweezers here, a decent set of tweezers, 5, 10, 15 bucks. These things are lifesavers. They've got the little grippy teeth on them. You can grab small components. I used to do a lot of PCB rework, so it's real easy to grab stuff with these and grip stuff, usually surface mount. This is all through hole. So what I'm going to do is I'm going to put my tweezers in here. I'm going to kind of arch it off of the board and add a little pressure to it. So that way I can help give a little bit of pressure on the component itself to push out. Because if I start digging into it with the iron, you're going to start messing up the PCB, digging holes because it is fiberglass, tearing off the trace, ripping pads, all that type of stuff. So as you watch here, you can see it flow. And just like that, the part came out. So if we flip this over here, there's my part. So the only issue is now that I've got all the solder here in the holes that I need. So as you can see, though, most of it kind of went back to where it was originally. So it's all back here, but you can easily, start to, you work your iron over it. It'll pull some of it up. It's not going to pull all of it, but you can get a fair amount off. So there's your component. There's it out. We didn't trash anything there. So what I'm going to do now is use what we call a solder wick. This is a pretty common product that is very handy. Let's see if I can't find my cutters. I need to trim a little off. So this fun stuff is called solder wick. There's different thicknesses and all that type of stuff, so you can get wide, skinny, whatever you need. The point of this is it's just basically a braid of wire that's meant to soak up solder when you apply heat. This one has no. Oh, I'm sorry. I was gonna say it looks like it didn't have flux, but it's no clean. So that means it's got a little bit of flux in there. So what we do here now is you basically rest some of this over on top of what you want to remove solder from, and then just put some heat on it. So we're gonna try that real quick. So it gets a little tricky because you do have to add some pressure, and then just be patient. You gotta wait. Be careful, try not to touch it, because it does heat up the entire thing, which can be painful. So if you see there, setting that heat soaked it up into the wick and removed it from our through hole there. And try it again. Like I said, I'm sorry, I'm a little shaky. I'm working through the phone screen, so depth perception's a little weird. So there's that second one. We're gonna move just a little further down the solder wick here. Add heat again. Wait just a little bit. Remove. There we go. So now all our holes are clean, and we didn't mess anything up. So the biggest thing here you need to remember is that heat is your friend and solder is your friend. I mean, this you know, who knows how old this is as far as stuff you're working on that's been around for a while. That could make it more fun to work on and get it to flow. So if you add more flow, it's gonna warm it up, and then also going to add flux to it, which is really nice, and make it much easier to flow. That's what really helps solder to flow is the flux. And in the center of this, I don't know if you'll really be able to see it, but in the center of almost all solder, there's a what they call a flux core. So with that being said, that makes that easy to take out. Now, if you could do the same thing to this component where you could use, we'll just do it, might as well. You could use the solder wick to remove solder off the component too if you plan on putting the same component back in. That's pretty easy to do. Be careful because there is high amounts of heat involved. So like I said, this wick will heat up, could burn you pretty good, and it takes a few times to learn that lesson. But if you haven't been burned yet, give it time, and it hurts. So I'm going to basically grab it with my tweezers, and it just looks like there's a little bit of extra here. I'm just going to try to clean up. Sometimes you don't need the wick, actually. You can just kind of flow it on the pin, and it'll be enough with the through hole being big enough to just simply slide it back in. So there's that. Let's take a look here. I'll use tweezers in case it's still hot. They do hold heat. And basically, we could probably line this back up just to show you that, you know, it's nice once you get those holes cleaned as far as putting the new component back in. Like I said, working through my camera, so this is a little tricky. But you can see there, goes right back in. No problem. So, if you have a new component that doesn't have any solder on it anyway, that makes it much easier too. So, there's that part. Alright, so now I'm going to pause and scrape off some stuff here. So, give me just a sec. I'm going to pause it and show you if you have the issue. From right here, this is really easy to put a new one in, right? Because you've got all your pads here and everything. You basically put the new component in, touch the soldering iron to it, and then just feed in solder from the other side, because that way it'll pull the heat through the part. Once the solder starts to flow, it'll flow over this pad, the part, everything, right? So you get a good solid connection there, and not a cold solder joint. A cold solder joint makes it look like it's actually connected when it is not. You're gonna have a whole lot of fun if that happens. So heater's your friend, solder's your friend, flux is your friend, right? So I am going to pause, and we're going to pretend that these pads got ripped off, and we'll go from there.